So methionine deprivation as a therapeutic strategy for diffuse intrinsic pontine glioma. Yeah, so I have to say this to me was one of the more exciting things that we found over the last few years. So we, again, with partially funded through DIPG Collaborative before, we'd done proteomics. So looking at the protein components of DIPGs. And when we were doing that analysis, one of the things we found was that there seemed to be alterations in the methionine pathway. So methionine is one of the essential amino acids. So it's one of the things that your body can't make. You have to eat it. And we know that methionine is important in how the cell functions. And it sort of just particularly twigged our interest because in DIPGs, because they have that histone mutation, and the histone mutation leads to a loss of methionine being deposited across the cell. And so we just kind of, probably a little bit naively, we're thinking, well, it's methionine, so maybe it's really important for DIPG. So we followed up on that. And when we started testing cells, both DIPG cells and cells where we took kind of normal cells and just put in the histone mutation, and if we take methionine out of the broth that we let the cells grow in, all of the DIPG cells die. And also cells where all we did was add in a mutant histone, those cells died. They did not like not having methionine. Now, normal cells also don't like it, but with normal cells, you can add in another amino acid called homocysteine. And normal cells can use homocysteine and make methionine out of it. But the DIPG cells and the histone mutant cells couldn't do that. So that made us kind of really excited. And there is a literature out there a little bit for other types of cancer. So breast cancer, for example, where people have tried this as well, like taking away the methionine. And so there does seem to be certain cancers that are particularly sensitive to this methionine deprivation or taking it out of the environment. And it's, I think, also exciting because so you can use this as a treatment either by, you can give another drug, which is a drug that basically blocks the methionine from being used, or you can actually just take it out of the person's diet. So, a vegan diet, for example, is already something like 80 or 90% methionine depleted. So I'm not saying maybe, depending on who you are, maybe it's not the tastiest diet on the planet, but it's a lot better than some of the other diets. And so we were really excited to try and look a little bit more into, is it something, because it's something you could add on very easily actually to any of the other therapies that we currently are trying for DIPG. And so we wanted to investigate two things. So the grant is broken into two different aims. So the first one is more of a basic sciencey kind of, how is this actually working? Like, what is happening to these cells when we take away this methionine, and how is it hurting them? And then the second part is we've got pretty good data on the cell cultures that taking away the methionine kills them, but how do we translate into humans? And the first way we do that is try and do it in animals. So we proposed a few experiments where we'll inject DIPG cells into the animals and then change the animal's diet, take the methionine out of the animal's diet, and see how that works on its own, how it works in sort of collaboration with some of the other therapies that we currently use for DIPG, like radiation, for example. So just as a way of seeing how could we move this into patients, and how much methionine do we really have to remove? Like, and there is evidence that it's not that you have to go completely like none, but if you drop it down, you can have the same effect. So that's sort of, in a nutshell, I guess, what the grant's about. So, I mean, I really, really want to thank the DIPG Collaborative. They've supported our research for many years, as Keith mentioned. We've had so many projects that we were able to really just try out, start things because we were able to get grants from the DIPG Collaborative. And I think this current grant is a good example of that. It's what I think is kind of like a cool idea that, you know, this will allow us to try out. And, you know, many of our kind of cool ideas that we were able to try out through the DIPG Collaborative have turned into big, major, you know, discoveries and have really, I think, moved the bar. And so I think, you know, it's important to remember that actually a lot of the stuff that we do and many of the other labs that are doing DIPG research, they all got started through money from DIPG Collaborative, and many people would not be doing this research if it were not for the DIPG Collaborative. So thank you very much for all you guys do.